Hey guys, in this video of our Algebra 1 course, we're going to be talking about properties of numbers. This is lesson 3 of Unit 1, and this lesson is really vocabulary heavy. In fact, that is kind of all this, all that this lesson is all about, and so there's going to be a lot of writing in this one. So let's dive in and get us going. All right. So there are several different properties we're going to be talking about. The first one is what I like to call the most no-duh property in all of math, and that is the reflexive property. Reflexive property. And what the reflexive property says is that for any number A is a variable that represents the number, A equals A. Mind blown. All right. This one in Algebra 1, we won't see this property a ton. It may show up on this lesson at some point. I don't know. We'll see. But this one is a really simple property. We use this one fairly often in geometry, so it's worth knowing. So the next property that we're going to discuss is the symmetric property. It says that if A equals B, A and B are numbers, right? Then B equals A. Which is nice, because if at a problem we end up with 5 equals X, we really like to see that X written on the left side, so we can just real quickly at the very end of a problem say X equals 5 and be done with it. Circle it and move on with our life. Yay, happy day. That can be really handy for situations like that. Oops, wrong direction. The next property that we're going to discuss is the transitive property. Transitive property is particularly useful. Oops. I can spell. I know sometimes on these videos it feels like I can't. The way I make these videos, though, I don't have much thought time involved. It's all kind of it's almost like these videos are live, all right? Because I don't really edit these much because it allows me to get them done quicker and out to you guys, which can be helpful for all of us. So the transitive property says that if A equals B and B equals C, then A equals C. Easy peasy. Nothing much to it. All right. Last property we actually kind of used in our last lesson. You can check the link in the iCard if you missed out on our last lesson for some reason. But the last property is the substitution property. The substitution property is pretty straightforward. And it says that if A equals B, then B may be substituted for A. Substitution property has to do with substitution. Surprise, surprise. Now, one interesting use of this, and we're going to see this in some examples, but I'm going to go ahead and let the cat out of the bag now, is if you have a problem, we're supposed to list the property, and the step looks like 5 plus 3, and then to go from that line to the next line, which would be 8, we're actually using the substitution property here, because we're substituting 8 in for 5 plus 3, because 5 plus 3, in fact, equals 8. So we're taking and we're substituting. So addition is not a property, it's an operation, right? And so we're using the substitution property to stick that 8 in place of 5 plus 3. So that's the only kind of weird place that you're going to see in this lesson when we do examples, and then when we do examples and whenever you do your homework or practice problems or whatever else, that's a use of the substitution property. So let's see. We're going to talk about additive identity next. Let me grab my white color back. The additive identity. Additive identity. Oh, add's got 2 D's, doesn't it? Additive identity. Okay. The identity, my identity is a word for me, right? And so additive identity is a number that you can add to any other number and it doesn't change its value at all. So think about it for a minute. What number can you add to any other number and it doesn't change the value? Did you come up with it? I bet you did, because the answer is 0. 0 is the additive identity. And so if we write this as a property, then we could say that A plus 0 still equals A. Easy peasy, lemon squeezy, right? No, that A is looking more and more like a 9. Sorry, y'all. Crazy fine. A. That's an A. There it is. The next one we're talking about is the additive inverse. Okay, the identity makes something not change. The inverse flips it around and it gets rid of it. We're going to use inverses a lot in this class because that's how we solve equations a lot of times, is with inverses. So the additive inverse. The additive inverse is how we get rid of stuff in equations, which we're going to look at a whole lot. So the additive inverse is what nullifies it. And for adding and subtracting, what makes a number go away and makes it disappear, if I have like 5 plus 8 minus 9, and I want that 5 to go away, right? If I want it to poof, I need this 5 to not be a 5 anymore. What can I add to anything to make it not the same? Well, that's the identity, right? So I need to turn that 5 into a 0. So for the additive inverse, I need to figure out what number can I add to something to make it turn into 0. What can you add to it? Well, you can add its opposite, its sign opposite. So the way we write the additive inverse is like this. A plus the opposite of A, or negative A. Both of those ways of saying that would be correct, both of them. Okay. So equals 0. So the identity keeps it the same. The inverse cancels it out, makes it poof away, right? So let's look at the same thing, but for multiplication. Okay, so for multiplication. The multiplicative identity. Is it itive or ative? Ative. Multiplicative identity. So the identity, it's what can you do to a number and keep it the same. So what if for the multiplicative identity, you may have already guessed, is going to be what can we multiply times a number and it stays the same, doesn't change it at all. Well, think about it. So what number can you multiply times any other number and it stays the same? Well, that is 1, of course. And so simply put, the multiplicative identity says that A times 1 still equals A. So identity doesn't, it's whatever we can do to the thing and not change the thing, right? So that's a multiplicative identity. Easy peasy lemon squeezy, right? What about the multiplicative inverse? Multiplicative inverse. Now, for the additive inverse, it was what can we add or take away or whatever to the number to cancel it, to poof it, to make it go away. So the same thing works for the multiplicative inverse. What can make it go away? Well, so what we need to do is we need to make it turn into the identity, right? So what can we multiply times a number and turn it into 1, right? So this one may not be quite as obvious if you've not seen it before. So the way we write this is if we have A times 1 over A, that equals 1, right? And I'm gonna kind of put this in a little bit of notes because this one, because I know fractions kind of scare people. They're not that scary. It's going to be okay. The reason this works is because how do we multiply fractions? Well, first we'd have to turn this into a fraction, put it over 1. A times 1 is A, right? And then 1 times A is also A. And A over A, anything over itself, is 1. And so that's why the multiplicative inverse is multiplying it times 1 over that thing, flipping it over. We also have another name for the multiplicative inverse, and that's the reciprocal. So if you've heard of the reciprocal before, the multiplicative inverse is just a fancier name for a number's reciprocal. One last property before we do a few examples, okay? So one last property. This one is nice and clean, and it is the multiplication property of 0. Multiplication property of 0. And this one you probably have seen before. In fact, a lot of these you've probably ultimately seen before. Of 0. Go ahead and write it out. That way you don't think that it's a multiplicative property, multiplication property of what? No, of 0, right? And that is if we have any number and we multiply that times 0, it equals 0. Easy peasy, lemon squeezy. Let's take a look at some examples of what we might see this on a homework assignment or quiz or whatever else. So taking advantage of those properties. So we're going to do an example. It's going to be example number 1. Example number 1 says evaluate 7 times 4 minus 3, close parentheses, minus 1, plus 5 times 1/5. We're going to evaluate that, and we're going to name each property used. Now, the trick with these is if you had a very robust pre-algebra at all, you've almost certainly evaluated rather big or big to big-ish expressions like this, and you could probably do it, and you could probably combine steps and all that kind of stuff. But if you're going to do this and you're actually going to name each property, you can't really combine steps, because if you combine steps, then you can't list the properties, right? And so you have to do different steps on different lines, and that's what we have to do with these. So I'm going to rewrite the problem is the first thing I'm going to do so that I have it in place and can do something with it. I'm going to give myself a little bit of space because I'm going to write the properties out here to the right. I think I'm going to change colors on each line too to make it really clear what goes with which. Is that bad grammar? I don't know. Let me know in the comments below. And don't just say it's bad grammar just to mess with me. If it's bad grammar, you got to explain it. So there's the thing. So I can see two different places to start. Now, in order of operations, we did parentheses first, so that's probably going to be our best bet. You could also, technically, since it's all out here on its own, you could do this multiplication step. But we're going to do this. We're going to do the what's inside the parentheses first. So 4 minus 3 is 1, right? So that's what we're going to change. Minus 1 plus 5 times 1/5. Okay, so what property did we use to get from this yellow line to that blue line? Well, this is an example of what I was talking about earlier, because this is the substitution property. We substituted 1 for 4 minus 3 because 1 equals 4 minus 3. I'm going to shorten my substitution property as subs. That seems reasonable to me. All right, what are we going to do next? Well, we're going to do our multiplication from left to right. So 7 times 1 equals 7. We're going to bring down what we haven't touched. Over 5. Now, what property is that? Which property did we use to get from one to the other? Well, this time you could make a case that we also use substitution, but because this is another specific property, we're gonna call it that. You could make a case for substitution, but there's something even more specific than that, because 7 times 1 equals 7 is the multiplicative identity, right? So I'm going to abbreviate that with mult ID, right? Easy peasy, right? So next, what are we going to do? Well, we're going to take care of this. 5 times 1/5. 5 times 1/5 is 1. And we know that because of which property? Which one is that? Go back and use your notes if you need to. You should be copying all this down, especially if you're one of my actual students. So to change from 5 times 1/5, that would be multiplication. So multiplicative something, right? Is it the identity? Well, no, it's not the identity. It is the inverse. So I'm gonna abbreviate that as mult-inv. Easy peasy, right? What are we going to do next? Well, the next thing we're going to do is we're going to do 7 minus 1. 7 minus 1. Is that any of the other properties? 7 minus 1 is 6, right? So 6, and then bring down what we haven't touched. 6 plus 1. Is that additive inverse, additive identity? No, it's not either one of those. So what did we use? Well, we used substitution. Because we substituted 6 in for 7 plus 1, because 6 equals 7, not plus, 7 minus 1. Easy peasy, lemon squeezy. Now the last step in the last line, we're going to use substitution one more time to end up with 6 plus 1 equals 7. And it's substitution. The way at this point in our life we can think about it as substitution, because it's not any of the other specific ones. So it's not one of those. It's probably just substitution. Easy peasy, lemon squeezy. That's all there is to problems like that using those properties. We've got 2 more properties that we want to talk about, and then we're going to do one more example that's a little bit weird and a little bit brain bendy, but it's going to be But there's going to be a reason why we do it, and I'll explain that when we get there. So 2 more properties. These ones are a little bit more English vocabulary heavy. Okay, so the first one we're going to have is the commutative property. Commutative. Both of these properties have a dual letter. This one has dual M's. The next one's going to have dual S's. Oh, but I didn't spell it right. Commutative. That's not right. It's not right. Oh. It is right. I don't know why my brain told me that was wrong, but commutative is correct. So don't freak out if you're writing in pen. You probably shouldn't be doing that, but you know, life happens. So commutative property says that if A plus B equals B plus A, and it also says that A times B equals B times A. So we can rearrange numbers. So an example of this might be, let me change colors, 3 plus 2 equals 2 plus 3. All right, because 3 plus 2 equals 5, and so does 2 plus 3. Right? So we can rearrange it. A way that I like to help people remember, and this works for some and doesn't for others, and if you have another way that you remember this, you can put that down in the comments or let me know in class. But to commute means if I commute to work, then I drive to work. So commute means to move from one place to another place. So the commutative property means that you can rearrange addition, subtraction, and multiplication, division, and it's the same thing. And that's what they say. So if we did, let's say, how about, oh, that's a bad, I was about to say 7 times 7. That's the same number. How about 7 times 8? 7 times 8 equals 8 times 7. Because 7 times 8 is 56, and 8 times 7 is also 56. So that's all the commutative property says, is that we can rearrange it as long as we keep the signs in the right place, and it's the same answer. The last property we're going to talk about is the associative property. The associative property. And it says A plus B plus C equals A plus B plus C. So we can group those numbers in different ways and it still works. We can group the B and the C together or the A and the B together and it works out the same way. So let's do an example. I'm going to put this one underneath. Right. Actually, no, let's keep it all the same. Let's say, let's do 4 plus 6 plus 2. And we're assuming that that equals 4 plus 6. And then plus 2. So let's work it out and see what happens. 6 plus 2 is 8. Bring down what we haven't touched. 4 plus 6 equals 10. Plus 2. 4 plus 8 is 12. Equals 12. So we can group it either way. So the way I like to remember that is if I am associated with something else, or this is associated with that, then they are grouped together. So the associative property has to do with grouping, and we can group them and do them in different order, and it's the same thing. It also works for multiplication. All right, so A times B times C equals A times B times C. Right? And so if we were to write that out and kind of prove that it works, let's do some fairly easy numbers because we don't need all that stress. How about 5 times 4 times 2? Does that equal 5 times 4 times 2. Well, 4 times 2 is 8. Bring down our times 5, right? 5 times 4 is 20. Bring down our times 2. 5 times 8 is 40, and lo and behold, so is 20 times 2. So see, we can group them in different ways. Let's kind of put some meat on this with one example, and then we're going to be done with this lesson. So this is going to be example 2. We're going to evaluate (5 times 7 times 4 times 2), and we're going to use we're going to explain what property we use in each step. So I'm going to rewrite this problem. Do the same thing. We'll color coordinate it so it's easy on the eyes and easy to understand. So 5 times 7 times 4 times 2. Now, you could just jump on this and do 5 times 7 is 35 times 4 and whatever else. But the reason why you might want to use some of these properties like the associative and the commutative is because it's kind of easier to do in your head, right? And so what we can do is first we can rearrange them. And if you move stuff to 5 times 2 times 7 times 4, if we moved the things, that's commuting, so the commutative. So I'm going to abbreviate that COM because that sounds reasonable. Okay. So now 5 times 2 is 10. 7 times 4 is 28. Now, what property did we use there? We did two things, but we used the same property. What property was that? Well, that was substitution, right? Now, why did we do that? Well, because 10 times some number, you just add a 0 after it. So that's easy peasy. So that is why we use that property here. So 10 times 28 is 280. So that's also substitution. By the way, I usually abbreviate associative property as ASSY. No, ASSO. ASSY is different thing. Because obvious reasons. Or you could do ASOC, right? Or you could just write it all out and not abbreviate it all. But that's what I do for obvious reasons. That's all there is to that. If you're in my class, you can find the homework for this in your homework locations. And if you, excuse me, if you're not one of my students, make sure you, even if you are, hit the subscribe and hit the like button. Remember, we are offering this entire Algebra 1 course for free, at least the lecture part here on YouTube. So giving us a like and a subscribe really helps us out. If you want to see more of what we're doing and more of what we offer, you can head over to emberlearninglabs.com. Thank you guys and have a wonderful day. Adios.